how are you, my dear students? I hope everyone okay. Today I have also selected the chapter 7. Here's the chapter 7. You know, it's also the physics based topics. Here's the physics based topics. We have selected the earth and gravitation. You know, the earth and the gravitation is also very important topics for your JSC exam. Today I have also selected the last topics. Here's the last topics, the lesson 6 and the lesson 7 and 8. Here's the lesson 6. The headline is the acceleration due to the gravity and the weight of an object are different at different places on the earth. And the lesson 7 and 8, the another very important topics. Basically, these topics is the variation of weight in a lift and in space, weightlessness. Again, weightlessness. Now, please everyone open the books. The page number is the 75. Here's the weight of an object depends on the acceleration due to gravity g. Here's the gravity is the acceleration due to the main factor is the gravity g. And the reasons for which the value of small g changes are also the reasons for which the weight of an object changes. Very important hypothesis maybe. The weight of an object is not an invariant quantity. Its value changes from place to place on earth. The reasons for which the weight of an object changes are described below. A first category is the A at different places on the surface of the earth. Here's the I also draw basically this structure. Here's I just also suspect it's also the earth and it's also the center structure and it's also the distance d. Here again and again I also repeat at different places on the surface of the earth. The weight of an object is different at different locations on the earth because of the shape of the earth and its different locations. 1. For the shape of the earth. Since the earth is not a perfect sphere, all points on the surface of the earth are not at equal distance from the center of the earth. Here, this structure is the center of earth and here also the another distance basically, and as the value of g at a point, depends on its distance from the center of the earth. The value of g becomes different in different places on the earth's surface. At the equatorial area, the radius of the earth is largest and the value of a small g is the lowest, very lowest structure. Basically, this structure is the 9.78. Again, I also repeat 9.78 meter per second square. It's also the lowest rate. Again, I also repeat at the equatorial area, the radius of the earth is largest and the value of g is lowest, 9.78 meter per second square there. This is why weight of an object is minimum in this region. As we move from the equator to the poles, the radius of the earth decreases and the value of g increases. Again, another structure is the 9.83 meter per second square. It's also the another decreases structure. Because of this, the weight of an object also increases. At the poles of the radius of the pole is minimum and the value of g is maximum. As a result, the weight of an object is highest in this region. Now, the another category and another structure for the diurnal rotation of the earth. Because of the diurnal rotation of the earth, the acceleration due to gravity gradually increases from the equatorial region of polar region. As a result, the weight of an object also increases as we move from the equatorial region to polar region. My dear students, another points for the increases of weight from the earth's surface. As we saw to higher heights, the value of the acceleration due to gravity decreases. Because of the greater height from the surface of the earth, the lower is the value of the weight of an object. Thus, the value of a small g is less at the top of a mountain. At a point inside the earth, as we go deeper inside the earth, the value of the acceleration due to gravity goes on decreasing. Because of this, the weight of an object goes on decreasing. As we go deeper and deeper inside the earth, again, when it's go the deeper and it's also deeper in the earth again, thus the weight of an object is less inside a mine. At the center of the earth, the value of the acceleration due to gravity is 0. Now, therefore, if we take an object to the center of the earth, there will be no force of attraction of the earth on the object and its weight will be 0. My dear students, again I also repeat basically our main topics. The acceleration due to gravity and the weight of an object are different at different places on the earth. Again, next structure and the next topics. The variation of earth in a lift and in a space woodlessness. The value of small g at a particular point on the surface of the earth is fixed, and therefore the weight of a person at that point is also definite. But even then, a person there may feel a change of this height, weight, and even feel weightlessness under special conditions. To understand the change of weight and weightlessness is a lift, we have to introduce the idea of internal frame of difference and the concept of apparent weight. That a system of reference moves with constant velocity. It is called an inertial system. Thus, an inertial system has no acceleration. Newton's laws are applicable only in inertial systems. In an accelerated frame, the apparent weight of a body differs from the true weight. Whenever a frame of reference is accelerated, an inertial forces arises from which we can find the apparent weight. If the frame, like our lift, has an acceleration a, again I also draw, here is also the a, and an inertial fictitious force arises given by minus ma in a direction opposite to the acceleration of the frame of reference. By applying Newton's law of motions F, again I draw, my dear students, is also the another structure. F plus minus mg equal to ma. We know F is equal to ma, or F is equal to m into g plus a. It's also the another reactions and also the another hints, dear students. Again, acceleration is a positive when lift is accelerated upwards and the felt weight of the person in the lift is greater than the real weight. If the lift is given additional acceleration downwards, the apparent weight felt is less than the real weight mg. If the left has a free fall, then a equal to g and f equal to 0. Therefore, the apparent weight is 0 and the mass in the lift will fail weightlessness. An object released from the hand will remain static. If the lift is static or moving with a constant velocity, the mass in the lift will fail the normal weight. My dear students, again I also repeat, basically I have just also select the last topics in this chapter. Here's again, please everyone see the books. The attractive force that exists between any two material particles in the universe due to their masses is called the gravitational force. Another, every material particle in the universe attracts every other particle, and the value of the mutual attractive force is the proportional to the product of their masses and inversely proportional to the square of the distance between them. This force is directed along the line joining the two masses. The attractive force that works between the earth and any other material is called force of gravity. The rate at which the velocity of a free-falling body changes due to the force of gravity is called the acceleration due to gravity. The ideal value of the small g acceleration due to gravity is the 9.8 meter per second square. The amount of material present in an object is its mass. The force with which the earth attracts an object to its center is called the weight of an object. My dear students, again I also repeat the earth and the gravitation. Basically, first category is the earth and the gravitation is the gravitation. What's the meaning of the gravitation? And we also know that the Newton's law of gravitation and gravitational force. Again, lesson 2 and 3, we also learn the gravity and the acceleration due to the gravity. Yes, we also know that G is equal to Gm divided by d square. Again, I also write them, my dear students. Here's the G is the gravity and also the Gm. Here's the Gm divided by d square. Here's the G is also the gravity and the d is the distance. Again, we also know the variation of the acceleration due to gravity. Here's lesson 4, mass and weight. We also know that clearly what's the meaning of the mass and what's the meaning of the weight and what's the relation between the mass and also the weight. Again, today I have also selected the acceleration due to the gravity and the weight of an object are different at different places on the earth. Yes, my dear students, I think that's all today. Goodbye.